all the hype for the last year or so has been around AI, generative AI, large language models. What does it mean for IoT? What does it mean for the world that we collectively here are working in it? Can you bring these large models to the edge as close as possible to where the data is generated by sensors in the environment the devices are evolving? Can you run these kind of models on microcontrollers, on microprocessors, on tinier machines that are not rack of servers in a data center? This is exactly what Mitko and I will be discussing on this new episode of the IoT Show. Mitko has a vast expertise in the domain and lots to say about how AI will not replace humans, but augment them. This is on the IoT Show. Hi, everyone. This is the IoT Show. I'm Olivier, your host, and we have Mitko today. And today we are going to discuss AI on the edge, on the tiny edge, down there, microcontrollers, microprocessor, this kind of thing. So, Mitko, before we get into the topic, who are you? Who's Mitko?
Hi, Oliver, and hi, everyone. Myself, 20 plus years now in tech. I've been jumping between IT and OT for the good decade and a half now, and been doing a lot of technical and pre-sales, again, technical jobs during my life. I've switched from engineering to the pre-sales teams and everything. We actually have met with Oliver working at Microsoft for a while. And now we obviously do a lot of interesting stuff in this emerging tech because everyone, I guess, is reading and is seeing these demos of taking AI down to microcontrollers or your desktop PCs or industrial PCs. And that's what we're going to talk about today. So where the hardware, the connectivity, the intelligence, and the data meet together on the edge, and what's the value of being there.
Awesome. And as you'll see, we'll put Mitko's LinkedIn profile down there. So if you're not yet following Mitko on LinkedIn, go ahead, because you're creating a lot of content based on your learnings. I like the way you're sharing with the community, and you're testing things like and you're actually on top of these models that are coming out like almost every day. You're just picking on a new one. I see your posts all the time about, hey, I tried this, and oh, I tried that, and I was like, how many hours do you sleep a day? That's crazy. Not many, right?
Not many, yes, but you have to be there. I don't know. I don't remember sleeping 8 hours since last year, March, when these open source models actually picked up and the tooling around them, because it's a really exciting time. So even late in my career, I'm getting as excited as a rookie in a company. You know, there is always something new every single day, and you really want to try it out, see how it works, and then share with the others what we have learned.
Yeah, the new shiny object. Well, that's a good thing to follow you, because then you do the trying for us, and then we can pick whatever you tell us is good for us. Let's discuss this trend of AI coming to the edge, right? And so
Mhm.
before we get into your perspective on that, if you look back at 20 years ago, we're starting to put intelligence, on devices. We had these microcontrollers, microprocessor, starting to grow, starting to get better, and we're coming from the word of like programming FPGAs and things that are like super hard to do and cannot do much at the end of the day, or extra specialized, to something that can run software that is developed on a desktop. And what do you see the trend being? So edge compute, yes, for sure. We've been bringing that intelligence at the edge more and more. These days, everyone is like, all the fancy discussions are around AI everywhere.
Yes.
Tell us about, from your perspective, OT, IT experience, what do you think have been the progress, and where do you think edge compute is at today?
That's an excellent question, actually, because we've been doing edge compute for decades. We had different names, etc., but we never had the unlimited compute that we have today, and also the unlimited dark compute that we have today. Do you know the dark computing term?
Yep. Yeah.
It's
But you can actually
for
explain
our guests.
for the audience here, right?
Yes, so that's the computing that we have existing within our equipment, we are just not utilizing it. So the processors don't work on 100% all the time. We don't use all the memory, we don't use all the storage. So that stays actually in the dark. And at the same time, we cannot transport more than 3 to 5% of all the machine data, as an example, for a vertical domain. We cannot transport it to the cloud. So we have this unlimited compute idling, the dark computing, and on the other hand, we don't have the full visibility of the assets and all this information because we don't have the capability to move everything to the cloud. But we've got to this point that today, if you go and just get a sensor, general sensor from the market, it has the compute capacity of a server at the time when I started actually working. So in the past, with the same compute capacity, we had to serve 20, 30, 50 people working. Now we have a single temperature sensor with the same compute capacity sitting there.
That's
And
crazy.
yeah,
That
it's
is
crazy.
crazy.
Makes it much easier to develop because in the past you had to be very focused on this ultra constrained environment. So nothing outside of what barely you need because there is no capacity to do it. Today, you have all the capacity if you want to run machine vision, if you want to run advanced algorithms on the sensor itself, you can do it. And you have the tools, you have the software tools, you have the easiness of deployment. So everything is there.
That's
So it's an
interesting. Yeah.
interesting time. Yeah.
I like this notion of dark compute because, like, when you were saying it, I was thinking of a light bulb, like this little one here, that is connected over Wi-Fi. So it has a Wi-Fi chip, which very
Yeah.
often are something that might be a microcontroller, an ESP32 or something that
Yeah.
can do more than connecting to my home automation system and turning on and off, right? It can do way more, as you were just describing. And my light bulb is dark. That's
Yeah.
interesting, right?
It could be the
Um,
home automation system with the right
yeah.
distributed compute. It is the home automation system.
Interestingly, you were saying that, okay, we brought edge compute, we've been doing that for a long time, we brought intelligence and code down there. We have not been able initially, and actually we're still not able completely, and we'll talk about that, to send all that data to the cloud to be processed where there is like virtually infinite resources for compute, for storage, and so on.
Yes.
You can't for many reasons, right? And we'll discuss that in a second. And you have this unused, unharnessed power that is out there, and that we can definitely leverage. But it's especially true in the realm of IoT and industrial IoT, where you can't, for many reasons, send that data to the cloud, like security reasons, or the infrastructure is not connected, or the bandwidth is, and the usage of that bandwidth is whether limited or expensive,
Yes.
like if you connect through satellite, for example. And you still need a lot of data to train and then to run these models that are pretty advanced. And how important, from your perspective and from the customers you're working with and the companies you're working with, how important is it, you think, to run AI at the edge versus in the cloud? Is it something you see like as a 50-50, or like in general, how do you see that trend of AI at the edge versus AI in the cloud versus hybrid?
The technology is a pendulum, so it swings to
Mm-hmm.
data centers and cloud, and now it's actually going back because today the compute resources we have on the edge are times bigger than the one in the cloud. And thanks to the cloud native development, we actually can have the same deployment mechanisms also for the edge, and we can have the life cycle of the applications, the deployment. I mean, we can have all the delivery, continuous integration fully integrated with these edge appliances, and we can use the same tooling that we got used to use on the cloud. And now we have much more compute there. We have more storage. We have all these capabilities. So what I see today is actually the machine learning and these advanced mechanisms, especially the inferencing, is moving completely on the edge side. On the service providers, they're actually doing inferencing next to their base stations. Then you have all the industrial space. Everyone has enough compute on premises. So the factory IT, they have every single factory has a data center with plenty of resources. If you go to the shop floor, you have all the DCSs and all these POCs. There are so many resources
Yeah.
that now we actually see a lot of retrofitting. So we see retrofitting with modules or AI code chips, FPGAs. Even some of them are using also NVIDIA, small NVIDIA edge chips
Mhm.
or Intel edge chips, etc. So they're actually doing the whole inferencing on a high speed on the very edge of the device, like where the internet ends and the real world starts. That's where now the AI and machine learning is happening. And if we look only in the industrial, so we are not going over the complete market, consumer, etc., but only on the industrial today, my guess is that 70% of all the AI and machine learning is happening on the edge, and then only 30% is happening inside the cloud and any kind of private tenants.
Okay. Interesting. So, and it's important for people who are not familiar with AI in general and machine learning. Inferencing is the model executing its task, right? It has, and at the end of the day, it's not, I would say, rocket science. It's not easy. It's complex, but it's inputs from sensors, processing, and then you have an output or outputs
Mhm.
plural, and what we call inferencing. The training of a model is something that is required to create that inferencing, processing, and that though is created in the cloud because you need a huge amount of data and huge amount of processing to create the models. Correct?
Yes, and also that is changing. So the latest trends with these large language models and domain specific models is actually changing it. Because in the past, if you wanted to build your own model and train it, you had to get all this data cleaned up. You need to have data pipelines. So it's data center slash cloud play. Now with the large language models, you can get a large language model which is already pre-trained on a big corpus of data that you need. And then you can finalize the training and the fine-tuning on the edge device, even on your laptop. So people are actually fine-tuning the model, so they're creating a sort of a new model based on open source based models, and that they're doing it on their development stations with NVIDIA CPUs or Apple Silicon. So that's also shifting now to the edge. It's much more effective. It's significantly cost effective compared to the cloud.
Things look all good and well, right?
Mhm.
As in, we have this compute available. There's a way to train and then to refine your models at the edge, or train in the cloud, refine at the edge, as you were just describing. So, and you have the right tools. So everything is perfect.
Yes.
Everything is easy, right? But actually, no, there are things you need to pay attention to. What are the caveats? What are the risks? What are the things you need to pay attention to when you want to run AI at the edge?
Yes, so definitely there are still risks, and they're mostly related to the advanced compute which is required, because advanced computing comes with the electricity consumption. If
Mhm.
we're just running usual IT OT operations, the energy consumption that we need from our chips is significantly lower compared to if we're gonna go and compute advanced models and do big calculations, mathematical operations, and working with vectors, etc. So definitely the power consumption is very different. And yes, we speak about dark computing that we
Mhm.
have sitting idle there, but it's idle and doesn't consume energy. So do we have the energy actually to power on all that unlimited compute we have on the edge?
Yep.
That's also something that we have to think about. Then a lot of questions in regards to security of the data at rest, because whenever your data is within the cloud, there are certain security mechanisms in place around the hyperscalers. I mean, we have worked at a hyperscaler company, so we know how security is, so nobody can actually go in and pick up the drives with your data.
Mhm.
Where if the data is just present within the physical environment on the edge, it could be really easily picked up. And if you don't have the right, let's say, hardware, trusted attestation, TPM security, etc., modules inside, a lot of your intellectual property actually can be physically stolen.
Yeah. 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 Devices, and that's a common thread for
Yes.
IoT devices in general. They're physically accessible. And here we were talking about data that is stored on that device or used on that device that could be intercepted physically. Yeah, totally.
And some of this data is highly kind of expensive intellectual property because
Hmm.
multiple of the algorithms to be developed precisely around predictive maintenance, etc., it has significantly high cost. It's competitive advantage. So many of the companies actually want to protect that intellectual property. Although they're using open source tools to build them, the secret sauce is inside the algorithms.
Yeah.
And if the algorithms can get stolen, or part of the data that you're also augmenting on the edge, that becomes like a real security challenge.
Yeah, and we'll see, not the topic of the day, but we'll see how confidential compute will
Yeah.
evolve based on this trend of AI at the edge. But not today, not today, Miko. I don't want to get you
Yes.
started now because we're here for 2 more hours. Before we get into the demo, um, how are, how are these models running on microcontrollers, microprocessor? Are they any good? Are they really doing something? What is the expectation that needs to be set when you start doing this kind of deployments?
That's the other thing, that in many cases, people who are not technically deep enough, they have extremely high expectations in regards to artificial intelligence and machine learning on constrained environments like 100 megahertz ARM CPU, etc. They're effective and they can nail down the right process, uh, the right data. They can clean up data. So you can do a lot. Still, it doesn't have this general artificial intelligence to go and figure it out, things that which are not part of the model training itself.
Mhm.
So there are certain constraints in that regards. What we see is in more and more cases, these systems on the chip, they have now AI core chips. So we have one CPU executing the main operating system and applications. And then all the machine learning is actually offloaded to another chip, which is specialized. So today, even the consumer boards like the BeagleBone from Texas Instruments and Raspberry Pis and others, they also started having AI core chips. Most of
Mm.
the industrial boards have them. So you have part of the system on chip. There is something which is specific, doing machine learning very effectively. So that's happening. I mean, as we
Yeah, yeah,
speak.
yeah. Yeah,
But we are
and
not
then
there yet for general artificial intelligence.
yeah, no, we're not, but there's one additional layer that comes on top. It's not about having your light bulb, take over the house or the world, right? It's
Yes.
about, developing and bringing more intelligence, but then you will be able to compose it, and you'll be able to basically develop entities that are composed of different sub-entities that themselves have a certain level, I would say, of intelligence or of capacity to react to their environment based on these tinier models specialized for this type of device, this type of environment, and running on these microcontrollers. Enough talk,
Yeah.
Mitko. Show us what you have, because you're doing some very interesting work and we like to see code. So
Mhm.
show us a bit about your experience working with large models and on
Yeah.
tinier devices and in all the shebang.
Yes. So I actually discovered all the magic of the open source large language models and tooling end of 2022. So it's fairly new. The first time I actually had tried them out, that was Walt, and then because of OpenAI and all the other companies actually putting a lot of resources to make them even better, the kind of wow effect went across the complete industry. Uh, Now, what we can discuss is mostly the motion of open source because, as you said, there is always something new every single day. And there are very effective frameworks nowadays actually to be able to run and work with these models on constrained devices. And the latest is, so this llama.cpp is a framework which you can use to run large language models across different operating systems. 2 days ago, they now have also llama cpp for Windows XP. So just to give you a perspective.
Yeah. Okay.
Yes,
So,
you
and
can.
that's interesting. You were talking about the retrofitting of existing equipment that
Yes.
might not be fit to run more recent operating systems, but are able, they have compute power, right? And so why not
Yeah.
leverage it?
Yeah, in many cases, there is the compute power on Linux, FreeBSD, Windows IoT systems, Mac OS. And all these effective frameworks are actually taking all this complexity and moving it across different devices. You can run them also on embedded controllers. So there is
Mhm.
also LAN CPP for ARM CPUs. And one of the examples is one of my favorite models is Phi. And it's not because we worked at Microsoft, but it's also because Microsoft Research did a fantastic job actually with providing this small Phi 2 large language model, which is very applicable for additional training. So you can
Mhm.
do additional reinforced learning from human feedback training, and you can adapt the output from the model to be specific for specific task. As an example, creating JSON payloads or creating certain configuration, because these models are not intended to be used by humans all the time. I mean, we use them because the chatbots become use case number one. It's easy. But the idea is that these models actually are going to become part of systems of systems. And that's where we're going to go and train specific, very domain specific knowledge and operations. And then other systems are going to use them. So it's not for the humans only.
Okay.
So Phi 2, this model, it's also quantized. So we can also represent the weights inside the model in 4 bits. So we can make it even smaller. The complete model is 1.7 gigs, and you can actually load it in the complete memory of a small device.
Yeah.
In our case, what we do, very simple. We're just running it from the command line interface. You can also embed it in different Python, C++, etc. It's written in C and C++, so it's fast. Just to give you an example how fast it is, we're just asking the model to create a parser for JSON arrays in Python. The model is loading, and that's the speed. And that's the speed that you can get from this is like a mid-range MacBook. I
Mhm.
tested it also on the lowest range MacBook, and also I've been using it on Windows in the past. So Windows 10, also on CPU only. You don't need GPU for all these models,
Okay.
which makes them quite exciting. And that's the second example. This is like an Apple only framework. Apple is the only major vendor that have not announced any move in the large language space, I mean significant move. You have
Yeah.
Microsoft, you have AWS, you have Google. So Apple is the only one keeping quiet. So I expect that there is going to be a lot of business for all of us around Apple when they actually go and bring this dark compute we have. Because
Mhm.
today, these MacBook Pros, they're more powerful than the servers you would be using in the cloud. So all this compute power actually move on your desktop. It's sitting dark. And if we're early enough in the game, I have the feeling that we can actually succeed to get our share of the multi-trillion dollar pie. This is a framework which is created by the Apple research team. You can see it's quick, but still, this example, like MLX, it requires Apple Silicon. It does not run on anything else.
Mhm.
Now the team is thinking to actually be able to provide you an MLX to Onyx export. So you can go and work on your Apple Silicon, then you can export it to Onyx, and then on Onyx you can run it basically on everything. You can run it on phones, you can run it on Windows, you can run it, I mean, sky's the limit.
Yeah.
So these are just two simple examples. And what you can do, you can build your own Copilot running on your laptop, fully offline, fully based on all the privacy that you need. There are open source models which are beating ChatGPT on performance and accuracy, and they're fully open source. Everyone can go and download them. The latest model is 26.4 gigs. So for 26 gigs, you are getting ChatGPT locally on your PC, and you can use it whenever you want for Copilot, for everything that you need.
That's interesting.
It is.
That's very interesting. But when you think about a Chat GPT, you think of it as being something that will dig the entire internet of data, right? And this is what these like
Yes.
26 gigs are about, in a nutshell. Um,
Yes.
but in many cases, in many scenarios, especially industrial automation, you can eventually consider having models trained on way less data but more specialized. We know
Yes.
that OpenAI announced the GPT's way of creating these chatbots that are specialized in something.
Mhm.
But in industrial automation, you could expect the same thing, where eventually you could have, and I'm just like making it up, but a way for a maintenance operator to come to a machine and to ask the machine, hey, bring up your user guide and tell me what can go wrong with this and that, and that thing can run locally based on only the data sheets and the guidebooks and so on of this specific machine rather than the entire internet, right?
You can go even further. I mean, if you are the machine builder, you can also get all your history with all the cases, all the resolutions, all the extra data that you have, and you can augment an open source model, and you can actually do it basically on your laptop. And you can put all these 20, 30 years of information about support cases, about documentation, about tons of stuff inside. So the remote expert is just one CPU away. The operator goes there, he doesn't need connectivity. The remote expert is on the CPU, it's a model. And then they can get all that additional information, which is not public, but it's part of the
Mhm.
model.
Yeah. And this trend is interesting because to me, it demonstrates that this fear that everyone has that, AI is going to take over and is gonna replace people and kill jobs and so on. I do see these examples as great example of how they are actually augmenting the humans. They are shortening the time of research, the tedious task of having to go and fetch the information. You'll still need to have an operator to ask this model what is the problem and how to fix it, but then the operator will do the work. So you're augmenting humans versus replacing them, at least in my view, in my perspective. What is your take on that? I know it's a touchy topic, right?
Yeah, I'm with you. I mean, we are far away from fully autonomous systems. We have them for demonstration, etc., but still the cost of running them and the complexity is far beyond anything applicable for the industry. So in most of the cases, the human will be there. It will be part of the loop and it's going to be augmented by the extra information and all these extra tools that he can use on his daily work. So humans are not going away, jobs are not going away. That's the good news. I mean, at least for all of us. It
It
gives us
is.
much more perspectives and it gives us, at least for me, it gives me something that I wake up like 6 a.m. in the morning and then I'm just sitting down and reading Archive, which is a website where you have a lot of this research and Discord channels because you have this. I love to say we're living in the era of scientists versus hackers. So we have all
Mhm.
these scientists spending decades on machine learning and mathematics, statistics, and research, and they build a model, and then a hacker is sitting down and he's testing something completely out of the blue, and then his model is beating the model which took decades to be built.
Yeah,
So it's an interesting time. It's a very touchy subject, especially for the people who spend decades learning.
true, true, true. Yeah. So to open up perspective, and before I let you go, I mentioned earlier that there's going to be this additional layer. The hype today is about the models and what it can run and what it can do
Yes.
individually, as standalone systems or devices, or an edge. But I do believe that there's an additional layer that will come on top that will be about distributing and orchestrating these pieces of intelligence. The same like robotic systems and infrastructures is a good example of that. When you have like robotics, whether it's a robotic arm, whether it's a warehouse where you have like many moving parts and robots picking up packages and like bringing them here and there, like in an Amazon warehouse. Um, so there are systems existing already for distributing these workloads that will be more intelligent thanks to these models and orchestrating all of that will make these systems even more intelligent because they will be able to benefit from each other's pieces of intelligence or specialty, right?
Yes, that's the whole idea also of the agents, if you have heard, where these agents are actually working distributed and then they're getting their tasks. In many
Mhm.
cases, they have to figure out how to complete the tasks. And that's the good thing with these models because they have so much information inside that the agent actually can go and figure it out a lot by itself without you explicitly training specific model around it. I'm with you. It's going to be part of system of systems. Today we have these nice demos for playing around and trying to understand what's inside these neurons and the deep neural networks. But then many companies already have started integrating them inside larger systems and larger products. And that's the future. It's going to be productized, and it's going to be augmenting us, not replacing the human beings. So.
Okay, we'll all become cyborgs. That's basically what you.
Oh gosh.
We're not
I
getting
hope
there.
not.
Sorry, like we are
Yes.
like in pure science fiction, but actually
Yeah.
not so much. And that's one of the things I really love about this IoT show, which is like getting to discuss with people like you who are hands dirty in what's making the future. And I like reading science fiction, and I'm amazed by how these writers from a few years ago were so dead on right about what's going on and where we're going. And we are accelerating the pace here, so it's fantastic. Mitko, you talk a lot about AI at the edge and industrial applications for that. And as we just seen, like you are playing around with the things that are just out. The ones that you are demonstrating are like 2 days old or something like that,
Yes.
which I think is crazy doing demos with that. But you're brave. I love that. So, well, let's keep the pace of innovating and sharing about all of that. Where do people find you? Is it like LinkedIn? We're gonna put a link down there.
Yes, that's probably the best way to reach out to me and to Oliver and everyone else from the technical community. LinkedIn is the business network. We're trying to keep it business. And that's where we are also sharing a lot of this useful content and useful learnings we all do.
Mhm.
Because as everything in life, we have to learn every single day. And that's where we are also sharing. So join us on LinkedIn, always open for discussions, always open also for beginners if you're interested to start working with this space of edge computing and running AI on the edge and figuring out different use cases for verticals, manufacturing, transportation, logistics. Reach out in messages, always happy to share and bounce ideas.
Fantastic. Thanks, Mitko. Thanks, everyone, for chiming in. To get in touch with Mitko, we're going to put his LinkedIn profile down here and also in the description of the video. Have a great day. Thanks for tuning in and watching the IoT Show. Mitko, have a good one.
Thank you. Have a good one.